Okay, now we go to practice quiz. Okay, composition of functions again, and problem number 1. Draw a quick sketch of the following curves. Plug in points into an XY table only if you need to do so. If you can quickly make this sketch without plugging in points, do that. Okay, so this first one, A, sketch will look like this. Y equals x squared. If I need to, I'll plug in points, but I think I can just say, well, when the input is 0, 0 squared is 0. Input is 1, 1 squared is 1, negative 1 squared is 1, 2 squared is 4, negative 2 squared is 4. I'm going to be getting this parabola shape like this. Rough sketch, all I need, like this. Alright, continue doing that with these two, with y equals x and y equals square root of x. Alright, so y equals x. When the input is 1, the output is 1, input is 2, output is 2, you get a 45-degree angle. And the same thing with negatives. Input is negative 1, the output's negative 1. So it's this line, or you could have seen it as y equals 1x plus 1, y-intercept 1x plus 0, y-intercept of 0, a slope of 1, rises 1, runs 1, moves over like that. And the next one, the absolute value of x. Alright, now this one is going to look just like this one over on the right. Because if the input is 1, the output's still 1. The input is 2, the output's still 2. Absolute value doesn't do anything to positive numbers. But with a negative 1, the input would be positive 1. Negative 2, it's positive 2, so on, and it turns out to be a V shape. Like this. Okay, now these ability to make quick sketches of these basic functions is going to be really important to us in a following section that we're going to be doing next week. But just give me a little feedback on 1, A, B, and C. next two. Draw y equals square root of x. Quick rough sketch. Only put points down in the table if you need to. And then do number 2, state the domain and interval notation of that function. I'll give you 30 seconds more. Alright, so this we remember that the domain of square root of x is just positive numbers. It didn't ask for the domain. But what does that mean on the graph? It means it's only going to be to the right of the y-axis. And when I go over 1, I get up 1. When I go over 4, I only go up 2, because the square root of 4 is 2. Square root of 0 is 0. I am going to get this shape over here. And I'm going to put a big fat dot over here on this end, because it's a filled-in circle that ends the graph. And this shape should look kind of familiar to you. It's really the upper half of a sideways parabola. If you continued the parabola on the bottom, it would go like this. And that's what we get for the square root function. The domain of one of these is, normally, x can only be positives. Here, x has to be negative, and then that negative is part of a double negative. So here is from negative infinity to 0, including 0. Because you can take the square root of 0, and you get 0. Alright, give me a little feedback on D and number 2. Okay, now, here is from something we had just recently on composition of functions. Do h of g of f of x. 30 seconds more. Alright, so all I'm going to do is I'm going to replace f of x with this as my first step. Okay, so this is just going to go in here. So then I'm going to get h of g of 2x squared minus 7. Now I have to do g of 2x squared minus 7. Now, but what does g really mean? G of anything is 5 minus 2 times that thing. And 2x squared minus 7 goes in here and here. So I'm going to get h of 5 minus 2 times 2x squared minus 7. So before I figure out h of that, I'm going to simplify this down a bit. These are going to distribute to here and here. So this is h 5 minus 4x squared plus 14. And then these two are like terms. I'll simplify this down a little bit more. Get it as simple as possible before I do the h action. 19 minus 4x squared. Now I'm going to do h. But what does h of anything mean? H of anything is, let's leave out x. H of blank is equal to that blank over 3 minus the blank. And 19 minus 4x squared goes here, here, and here. So I'm going to get 19 minus 4x squared over 3 minus 19 minus 4x squared, which is going to equal, the top stays the same, the bottom I distribute that minus sign. 3 minus 19 is negative 16. Double negative on the 4x squared, and I get this. And that is where I stop. What did I just accomplish? H of g of f of x is equal to this. If you plug in x into this nested set of functions, you get this big function right here. Alright, give me a little feedback on number 3. Okay, more details the better. And here are some of the problems from the homework. I'm just going to have you, they're either ones that were assigned or right next to ones that were assigned. I'm just going to kind of give you a little more practice on this. I'm going to go ahead and do number 44 right here. This, by the way, was a mistake. "30 seconds more." You always work from the inside out, so f of 1, we look here, we read straight up and over, and we get that has a height of 3. So now 3 is my input, so I read straight up, and then read its height, and I get 4. Okay. Quick feedback on number 44. Let's do number 70. "30 seconds more." Okay, the notation, you just replace it with nested parentheses, keeping them in the same order. Do the internal one. G of 1 is 0. Now do G of 0, and you get back to 1, like this. Okay, a little quick feedback on number 70. Let's do number 31. "30 seconds more." Alright, I need to find a g of x. I'm going to focus on the g of x first. That's the internal function. So for instance, on this one, if I told you find h of x if x is 5, what's the first thing you do? You multiply it by 2. And then you subtract 3, and then you take 1 over that. So you'd work from the inside out. So if g is the internal function, the thing that gets on first, let's just have it be everything inside that big root. Now this isn't the only way to do it, but this is one way to do it. And then f of x will be, let's just say that last part, cube root of x. So we take the operations in this and we kind of separate them. I separated this one all by itself. And then let's check. Let's put it in red. So if I did f of g of x, this would be f of, now g of x is 1 over 2x minus 3. And f of anything is the cube root of that thing. And in fact, it gives me exactly that. It checks. And another way to look at this problem is, you might have seen this before, but this might be totally new to you. One way to look at a function is to think of it as a function machine. What goes in is some number x. And the function machine, so if this is the h machine, the first step, what would you do? Remember, if I said x was 5, what would you do? You'd multiply by 2. What's the next thing you do? Subtract 3. And the next thing, you'd flip it over or reciprocate. And then all of that, we decided to have this be g. And then the last thing was take the cube root. And we'll call this f. And we could have broken it up into different places. For instance, I could have done f and g of x being just the first two. 2x minus 3. F of x is reciprocated and cube rooted. Could have been, these first two is g of x and the last two are the f of x. This would give me exactly the same h of x in the end. Alright, a little bit of feedback on this one, number 31. Mariah, understand this one but was confused on number 30. Okay, well, let's do another one then. Let's do number 30. So, we're kind of running out of colors here. Let's take red. Everybody do number 30. Thirty seconds more. Alright, so if I told you x is 8 and I had you compute h of x, what's the first thing you would do to the 8? You would take the cube root of it, and then you would add the 4. So for number 30, kind of natural way to look at it, is, shrink it a little bit. The inner function would be the one that you would do first if you're computing h of x, and then the outer function is just this plus 4 over here. Alright, now let's go and let's do number 13. Enlarge that a bit. Alright, let me put this down. F of g of x, do the inner one, x squared plus 3. F of anything is the square root of that thing. And then if we do g of f of x, we got to do the f first, and then the g is that thing squared and you could FOIL this out or you could leave it the way it is, just like that. But what we notice is you get two entirely different answers. When you do the composition in one direction and when you do it in the other, almost always you get different answers. Once in a rare case, once in a while, you'll get the same answer either way. But almost always, it's different answers. When it matters the order in which you do it, there's a name for that. So, 2 plus 4, doesn't matter what order you do that. 2 minus 4 and 4 minus 2, it does matter what order. What's this called when the order doesn't matter? Does anybody know the name of the property here? Anybody? It's called the commutative property. Of addition. Means they can trade places. They can, if you commute back and forth to work, you go back and forth. You can trade places with these two things and you still get the same answer. There's a commutative property of addition. There's no commutative property of subtraction. If you compute, you change them around, you get a different answer. The same thing with composition, turn them around, you get a different answer generally. So it's not a commutative operation. Alright, and I think we're good with that. And let's just do this last one, number 36. Thirty seconds more. Alright, p of negative 3 is negative 3 squared plus negative 3, which is 9 minus 3, which is 6. To solve p of c is equal to 2 does not mean c is 2. It means this 2 goes and replaces p of c. So it really means solve 2 equals c squared plus c. This and p of c are interchangeable, so when I saw the p of c up here, I replaced it with 2. Now I'm going to subtract 2 from both sides. I can put equals 0 on this side, or I can put it equals 0 over here. It doesn't matter. Alright, this is a special kind of equation. If it didn't have the c squared, and the highest power on the c was 1, we'd call it a linear equation. When the highest power is 2, we call it a quadratic equation. Quadratic equations were one of the focuses of the class prior to this one, intermediate algebra, is to solve a quadratic equation, you solve it by a factor. And if it factors, you can get it. If it doesn't factor, you solve it by the quadratic formula. And let me just show you the quadratic formula in case it's been a while, in case we need to use it. Quadratic formula is this. F, and I'll put it in its normal letters. ax squared plus bx plus c equals 0. Then the solution is x equals negative b plus or minus square root of b squared minus 4ac all divided by 2a. And this formula, in case you don't have it memorized, you are assumed to have it memorized. Every class that has intermediate algebra or higher as its prerequisite, including your science classes and future math classes, they will all assume that you have this formula memorized and you can pull it up and use it whenever you need it. And if any of you know of an engineer, even if they're retired, 80-year-old engineer, you should try a little experiment. Come up to him and ask him, what's the quadratic formula? And my bet is no matter how old they are, they'll spit this formula right out. They use this kind of stuff pretty regularly. They get it ingrained. And so, quick exercise right now. In my experience, most college algebra students need a refresher on this. They've forgotten it by the time they get here. So I want you to study it for a moment, and then look away, and then write down the quadratic formula from memory. Okay, now let's return to this problem up here. If it factors, we will factor it. C times C gives me C squared. When you're factoring, you don't do the numbers next, you do the signs next. These two second places, they're going to be filled with numbers that when I multiply them together, it's going to give me a negative result. So they cannot be the same sign. If they're like both negatives, then a negative times a negative would be positive. So they have to be one positive, one negative. And then we're going to put 2 and 1. And since the middle term is positive, I want the larger one to be positive, smaller one to be negative. Now, once I have it factored, see, because now you can check the middle term. 2c minus c will give you 1c. Once I have it factored, I can immediately look at this and say, oh, my solution if c is negative 2, I will get negative 2 plus 2, which is 0. 0 times negative 3, 0 times anything is 0. And another solution is c equals 1. That's it. So the original problem, solve piece of TC equals 2, has these two solutions, negative 2 and 1. Okay, a little bit of feedback on number 36, please. One person needed that reminder. Maybe that's worth it. That's nice. Somebody still had it memorized. All right. Are there any unanswered questions from the homework before we get on to the new material? Anything anybody wants me to go over?
I do have a question. So if we turn things into spot check, we don't have to turn them into homework if they're all done, right?
Correct. If there's no changes you need to make, then you can leave the homework thing blank. And when myself or my grader is grading it, if we see that there's nothing uploaded for 5.7, we will look in the 5.7 spot check and we'll grade that. We'll assume that that's what you wanted to have happen.
Okay, perfect. Thank you.
You're welcome.
What if there's nothing? What if we don't put something for spot check, but do it for the homework? Do we get points docked off for that?
All right, yes. The spot check is worth 3 points, but that has a time limit on it. You cannot upload anything late into the spot check. The regular part of the assignment is worth 7 points. So if you miss out on the spot checks, the maximum you can get is 70% on each assignment. So make sure you're uploading something for the spot check in time each time. Does that answer your question?
Yes, thank you.
You're welcome. Anything else? It always takes a while to figure out a new system with a new class. All right. Composition of functions. We're going to be doing more on that today in a kind of application way. We'll see why they get used so often and so on. But we're at a break time. We will start again. At 1:28 in 15 minutes. And does anybody, before I take my break, anybody need to speak with me individually?
Yeah, I have a quick question.
Yes.
So I didn't enter anything for the homework, like the 3.1 homework.
Uh-huh.
But so my spot check got a 3, but I got a 0 on the homework.
That's a mistake. Sometimes my grader needs the reminder. Then he forgot to look at that. So your name is?
Amari. I resubmitted my spot check on the homework, though. I don't know if that helps.
I'm
this morning.
surprised it let you, because usually there's a time limit and you can't submit anything later on that. All right. So Amari 3.1. I'll send an email to my grader to have him look at your 3.1 spot check. Thank you.
Okay, thank you.
Mm-hmm. Anybody else?
Professor?
Yes.
There's a couple more of us that have the same problem that we're talking about it on the general text or the main chat.
Okay. I was just speaking with my
Where are you?
with my grader this morning, and I reminded him of that because he graded for me last semester.
Oh, were you?
But I think he needed that reminder. So, all right.
Okay.
Who else is that? Tell me.
It looks like Amari, Sherilyn, and Lizzie. Oh, and Ariana too. They're all, yeah. So Amari, Sherilyn, Lizzie, and Ariana.
Ariana. And you are?
Jeremy.
Jeremy. All right. I will let him know. All right. Thank you. Anybody else need to talk to me?
I gotta come.
Jeremy, if you could mute, we can still hear you. I think you gotta turn off your mic. Hey, Quinn. Just ending our break. All right, so let's get going again. And more on composition of functions. And here's the situation. All winter coats have been on sale. $100 off. Some have still not sold. As well as being $100 off, these coats are now reduced to 75% of the sale price. So if it was like, a $500 coat, it got $100 off down to $400. And then 75% of the $400 was reduced. Now reduced to 75. So didn't reduce by 75, but so 1/4 off. Okay. So a coat's original price was $900. Find its price after the first markdown and after first and second markdowns. So go ahead and work on this on your own. When you get your answers for both, put them into your group chats, but don't hit enter yet. And reminder, when I say that it's time to enter that, if you're stuck and you have no answer, you need to put that in. Say, I'm stuck or something like this, but you got to participate in the group chat. Okay, go ahead and hit enter and look at what other people are getting in your group. And reminder, group leaders, your job at the beginning of class was to remind the group who is the spokesman for the day. Otherwise, I'll call on the group leader if I don't get any response. Okay, group 6. What do you have after the first markdown?
For the first markdown, we got $800.
Great. And after the first 2 markdowns? Still group 6. What do you got there?
There, we have a response for the second part.
Okay, just for the first. Okay.
Yes, sir.
All right. Thank you for that. And let me switch to group 1. Do you have anything after the first and second markdowns?
Well, we put for the first markdown $800 and for the second markdown $600.
How did the 600 come about? Do you know?
Well, the way I did it is I multiplied 800 by 75 and then I divided it by 100.
Ah, very nice. So you took the 800 and multiplied it by 75 over 100 and divided by 100. Or you could have taken this times 0.75, because 75 over 100 is the same as that. So 75% reduced to 75% is you just take that percentage and multiply it. If it was reduced to 10%, you just multiply by 0.10 and so on. All right, so these are the prices. So 25% off reduces it to 75%. So this is really 25% off, but I made it a little bit easier for you to 75% of their sale price. All right, now let's go to the next one. A coat, original price was $1,300. Find its price after the first markdown, after first and second markdown. So go ahead and work on this on your own. And enter your answers into your group chat. Okay, so this time I'm going to write down the answers. I'm going to kind of show the process. 1,300 minus 100 is 1,200. And then we take the 1,200 as our input, multiply that by 0.75, so 3/4 of that I think is going to be 800. Did I do that right? Everybody agree with that? Okay. So now it gets a little tricky. Coat's original price was X dollars. Find its price after the first markdown, and then after the first and second markdowns. And as you get your answer, type them in to your group chat, but don't hit enter yet.
Shouldn't it be 900?
Ah, thank you. Let me check that on my calculator. I did this on my in my head. I think you're right. Yep, 900. Thank you very much. All right, take your answers and hit enter into your group chat. Discuss that briefly in your groups. Excuse me. All right, group 2. What do you get? What's the price after the first markdown?
For the first one, we got x minus 100,
All right.
and the second one we got that answer times 0.75.
And so which did you write first, the 0.75 or the previous answer?
The previous answer.
Previous answer
Yeah.
times 0.75.
Yeah.
I like that. And it doesn't matter where the 0.75 is. It could be up front or in the back, because multiplication is commutative. You get the same answer no matter what order you put it in. All right. Any questions on this? So my initial instinct might have been to write 0.75x for this next one, but remember you had taken the output of the previous one and taken that times 0.75. So we couldn't do it just times x. We had to take it from the output of the previous one, multiply it by 0.75. All right. Now, x is the price of a coat. F is a function which gives the sale price after only the first markdown. G is a function which gives the sale price after only the second markdown. H is a function which gives the price after both markdowns. Find all of these, F, G, and H of x. And if you're only able to get, part of it, or F, but make a guess, at least on some of this. And put your answer into your group chat, but don't hit enter yet. Go ahead and hit enter, chat about it in your groups.
I think I'm in a group.
Who are you?
Mariah.
Mariah Ruiz?
Yes.
So you got Discord to work, finally, right?
Yes, finally.
All
I had
right.
to delete it and then reinstall it.
Okay, so in Discord, you see where I am, where it says text channels? Above that, should be like a group. And you're actually in group. You're in group 5. All right. Landon, can you put Mariah Ruiz into group 5? She just got on. She hadn't been in Discord before.
Yeah. Give me one moment.
Multiple problems. Okay. Thanks for letting me know, Mariah. We'll fix that.
All right. I see. Group 5. You said.
Yes, group 5.
There they are.
All right. Super. So now.
And if you want to know how to do that yourself, just click on them. Go and click on their profile picture.
Okay.
And it'll have a plus button, and you can give them whatever roles they want. So go and press that plus button just as a tester, and it'll give you all the roles. Groups 1 through. Yeah.
All right. Thank you. All right. So. Let's come back to here and group 3. What do you have for f of x there?
We got, for f of x, we got x minus 100.
All right. So if it was $1,000 coat the sale price would be 900. Okay? G of x, what do you have for that?
X times 75.
X times 75, like this?
Yeah, like, but it was like we put it as a decimal.
0.75?
75%. Yeah, 0.75%.
Okay. So if we put a decimal in front of that 75, then it means 75%. Because 75 per means divided by, cent means 100. 75 divided by 100 is 0.75. You could do it x times 0.75, or you could have put the 0.75 in front and made it 0.75x. Either way. What do you have for h of x?
X, or in parentheses, we have X minus 100 times 75%.
All right. And then notice these answers are consistent with what we were getting up here. But we had one new one, this individual one, which was just taking 75% of the previous price, which is 25% off. All right. Now, which of the following is true? One of these two statements is true. That h of x is equal to f of g of x, or h of x is g of f of x. So, get your answer and type it into your group chat, but don't hit enter quite yet. Okay, go ahead and hit enter. And you can chat about this. All right, group 5, which one of these is true?
We said g to f of x.
The first one?
Yes.
The first one you're saying is true, and why do you think this one's true?
Because we first have to subtract 100 and then multiply.
All right. So we've got to subtract 100. But when you're doing f of g of x, which one do you have to do first? The f or the g?
The g.
Ah. So the one that has to come first would be the 0.75x, and that's actually going to rule this one out. The one that has to come first is the inner one, right here. This is the one that's true. Because we would subtract the 100 first, and then we would multiply by the 0.75. Kind of looks, the way this is written, x times 0.75, kind of makes you think that it's, but that if we put it 0.75x, it's a little more, it seems a little more understandable. All right, now let's label each arrow in the diagram below. 3 arrows, 3 letters, F, G, and H. So, and notice what we did before. We said it's the second case. So, let me give you a minute for labeling the arrows. Put your answer in your group chat, but don't hit enter yet. Okay, go ahead and hit enter. You can chat about it for a little bit. Okay, group 4. What do you have here?
Huh?
Yes?
We aren't entirely sure. Is it okay if we pass?
You can always pass. Passing is totally fine.
Woo, we passed the class.
Pardon? If you pass the class? Yeah. Okay. I'll open the floor. Anybody want to let me know how they think this should get labeled? Yes.
The top one, can I go?
Yes.
Okay. The top one would be H, the bottom left would be F, and the bottom right would be G.
All right. And why did you think the bottom right was G?
Because after the first markdown,
Uh-huh.
you do the 75%, which would give you final price.
Ah, yes. G is the second markdown, and its input is the price after the first markdown, and its output is the final sale price. F is the first markdown. Its input is the very original price. Its output is the price after the first markdown. G is the thing that takes the original price and sends you all the way to the final sale price over here. All right, so let's look at this in the sense of, let me get a little more space here. If I had a coat that's $1,300, original price. Now, F of 1,300 is 1,200. It takes an original price, sends it to price after the first markdown. G of the 1,200, it's got to take an output that's after the first markdown. You can't take 1,300 as the input, you got to take the output of that. And then 75% of that is 900. Meanwhile, H of 1,300, remember the H function, H of X. I like having the 0.75 out front because it looks a little nicer. Has the two markdowns. It's subtract 100 and then times 0.75. So it's 0.75 times 1,300 minus 100. Now that turns out to be 1200. 0.75 times 1200 is your 900. So notice what H is doing, taking an original price and mapping it to a final sale price. And so that's why it's the upper arch. And you're starting to see what composition of functions really is. And we use it in both directions. Sometimes we take a very complex situation and we break it down into all the little parts. So then we can analyze each of the little parts and say, ooh, how might I do these separate or improve one of these aspects of it? Sometimes, and in what we started with in that case might have been the overall. We knew the overall input to the overall output, and then we kind of added detail by saying, oh, what were the intermediate steps in between? Sometimes it's the opposite. Sometimes we have all these intermediate steps and we only know how to get from an input to the final output by going through all the intermediate steps, but then you could combine them all together and say, all right, what would be the function if I just went from the original input to the final output? That was this case. We had this first markdown and then we had the second markdown, but then we were able to put them all together into this giant function. Okay. We do them in either direction. And this is the composition, that little circle. Let me get this. Composition of two functions is combining them so that the output of the first function is the input of the second function. Two examples of this are multiple discounts, like we just had, $100 off and then 25% off. And a discount followed by a tax. This is really often the case in retail. 10% off, you have to do the discount first, and then they got to add 8.25% for the tax. Okay. Using this idea with multiple functions, so it doesn't have to be just two, it could be tons of functions, is the math behind the breakthrough idea of the assembly line, which forever transformed mass production. Does anybody know who came up with the idea of the assembly line and put it into use in a huge way? Where did that first happen?
That one idiot.
Yes, who's that idiot?
Something McFord. Ford. I think I'm stupid.
Henry Ford. With the car that they made was the Model T. And his big famous saying is they can have it in any color they want as long as it's black. And they just cranked out tons and tons. It's this model up here. He analyzed prior to Henry Ford, every person that worked on making a car did every job. You put on the wheels, you put on the steering wheel, you put the seats in. You had every aspect. And making cars was really slow and lengthy process, and the cars were very expensive. And Henry Ford came up with the idea, all right, we'll just have one person do just one job all day. And that person just puts the seats in. That's it. And but then right after that person is somebody waiting to put the wheels on. But they can't do their job until the person in front has finished with his job. So one slowdown in the chain could mess up everybody after it. So they had to really refine the system so that all the steps took roughly the same amount of time, so that they could just be, sending one car through, and one person does the same job over and over and over and over again. And what happens is that one job becomes super efficient. And they were able to crank out a whole lot more cars this way. Now my I have a large family. I have 5 sisters and 1 brother, and I grew up in the Detroit area, just north of Detroit. And my 3rd oldest sister, she married this guy who my dad had worked for Ford, and he was in management in Ford. And so when my sister married this young man, my dad, and he had kind of, going nowhere job. My dad helped him get into Ford in the assembly line. And now I was the 2nd youngest, so this was, my sister and her husband were much older than me. But I remember talking to my brother-in-law and him telling me when he first started there how, the days seemed so incredibly long for him. It was an incredibly boring job because he was just doing the same thing over and over and over and over again. But also, he said, it was this people that are doing the same job over and over and over again who then realize how it can be done better. And so a big part of what they were doing was when you had a suggestion of how to make your work easier, they'd actually pay them. And they'd give them, a nice big bonus if they came up with the idea of how to make this job go quicker and better and be more efficient and make less mistakes and so on. So they were really encouraged to think about what they were doing, how to do it better, and got amply rewarded for it. And that job turned out to be really good for my brother-in-law. He eventually got enough time in the union that he was able to, apply for being a plumber. And then he really liked that job. It had lots of variety. He was doing something different all the time. He always hated when he was doing the assembly line. But that has also been given credit in the history of the United States. Some historians say that it was because of the assembly line that we started having the creation of the middle class in America. As Henry Ford was making so much money, he decided he wanted his workers to be able to afford his cars. And so he started paying them good wages. And prior to that point, generally speaking, labor workers earned very, very little, just kind of survival type of wages. And when the assembly line started getting going, there was just like lots of product out, and they could afford to pay people a lot more, and then all of a sudden we are starting to get a middle class. We just had very wealthy people and very poor people prior to that. But the idea behind this was Henry Ford said, here's from beginning to end product of the car. We can break it down into all these little steps. The composition, it's essentially a mathematical idea, that breakthrough in this. And same kind of thing, same kind of thinking is required to solve all kinds of problems now. When the president of a company is like, the company is going, they're having really financial difficulties, and they might be going under. How do they analyze and figure out what's going on? They'll look whatever the product of that company is, and then they'll look as if it was assembly line, even if it's not assembly line. They'll break it down into individual tasks, and then they often bring people in that are efficiency experts that'll help, and they might tap into the resources of the people that already work there, that already know, we could be doing these things a lot more efficient. But they often have to break down the tasks first. And it's the same kind of thing with the composition of functions. All right. Any questions or comments? All right, let's roll on here. All right, so the homework for today is the worksheet. And it's so if you're in, let me go back in here. let's send you to modules. Okay, composition of functions. And so we've been doing, that was 3.4. Composition of functions worksheet. If I go into here, do the composition of functions student version. And then it has the instructor version. So everything that we were doing today in class was this worksheet, and then all the answers are here with the worksheet as well. And then the homework based on this worksheet, and you upload this, student homework, on composition of functions. Alright, now the student homework on the composition of functions, your horse eats, you own eats 4 bales of hay per month and so on. This has, I repeated that thing down here as well. Okay, and then the composition of functions, stuff that we did in class, here's some of those answers. Right, but those are all available in the modules. And so this is what you're going to be doing for your homework. And any questions?
So does this mean we don't have the 3.5 spot check due Monday?
So let's come back over here. Spot check of 3.5.
So that would be due Wednesday, next Wednesday.
That says that's due February 10th, which is next Wednesday. That is correct. All right. Spot check of composition of functions worksheet, though, that is due Monday.
Okay, thank you.
You're welcome. Okay. And anything else? Any other questions?
I forgot to submit my homework or the spot check at 12:30, so it's not letting me submit it now.
Correct. It times out at 12:30, so you can't do spot checks late. Since we're just getting used to all this stuff now, you go ahead and email it to me, and I'll give you full credit for that. Okay?
Thank you.
All right.
Can I also do that? Because
Yes,
I wasn't able.
anybody can do that now. Yeah.
All right.
We'll be loose and easy for a while here as we all get used to a new system and putting in these deadlines and such.
Okay. Thank you.
You're welcome. Any other questions?
Is there anything we have to do for our groups?
No. The group, I was giving groups a specific assignment just for the first couple weeks of class. And now that portion has ended, and it is just to initiate group dialogues. So I'm not going to give you any more specific group things, but I'm going to highly encourage that you keep doing something similar to that. That you at least be emailing each other and saying, hey, I couldn't do number 16, or I got this for number 16, what'd you get, and so on. And or you could be getting together, you know. But anyway, I just kind of wanted to give you that exposure to it, and then let you decide how you want to go from there. Anything else? All right, we will stop here today. One of the very few days that we end a little early. Y'all have a great weekend.